going to cover section 4. We're going to talk about three-dimensional figures. The first type of three-dimensional figure we're going to talk about is called a polyhedron. And a polyhedron is a solid bounded by polygons called faces. In these polyhedrons, we also have a vocabulary word, and that word is the edge. So the edge is this segment that is formed by the intersection of two faces. And then the vertex of the polyhedron is the intersection point of three or more edges. The plural form of polyhedron is either polyhedra or polyhedrons. The picture here, that is pictured down at the bottom, this is actually called a trapezoidal prism. And when you name these polyhedrons, you're going to be naming it based on the shape that is the base. Now, what you're going to see is sometimes they like to trick you in the homework and on tests and quizzes and standardized tests, and they don't always sit the polyhedron on its base. For example, here. This prism is not sitting on the base. The base is this trapezoid that is right here. This is the base. So whatever face you have two congruent faces of, that is going to be the name of the type of prism you have. Or when we see pyramids, the same thing. Now, what I'm going to do is show you my glove box over there, and I'm going to demonstrate from that real life example what a face is, what a vertex is, and what an edge is. So next we have, these are different types of solids. Now, for something to be a polyhedron, it has to have polygon faces. It cannot have any curved edges. So for example, the first one is a prism, and that would be a rectangular prism. And then the bottom, since I don't know anything about that pyramid's edges on the bottom, I would just say that that would be a rectangular prism. If I had congruency marks here, then I could say it's a square pyramid. But what you're going to be filling in is the shape of the base in front of the word prism or pyramid. So both of these, I would be filling in the word rectangular, prism, and pyramid. Unless I added the congruency marks, then I could actually say that this is a square pyramid. Okay, so that's what you would look for. Now, non-polyhedron, that would be like cylinders and cones and spheres because they have curved edges. The sides are not made up of polygons. So a prism, in order to name the type of prism, is you're going to use the shape of the base. And just like we saw back on that trapezoidal prism, they don't always sit the prism on its base. It might be sitting on its side. But what you're looking for is the shape that you have two of. So notice in this picture, I've got a pentagon right here and down here. So whatever shape you have two congruent faces of, that would be the name of your prism type. Notice the lateral faces, which are these going up along the sides. These are going to be parallelograms. Now, sometimes they're going to actually look like rectangles, but if you remember back from your quadrilateral chapter, all rectangles are parallelograms. So they generally, for the definition, just say that the lateral faces are parallelograms. And then they're going to connect the vertices of the bases. The altitude or the height of a prism will be the perpendicular distance between the bases. So for example, on this figure, you would look for a little right angle, and then this could have been your height. Because again, it's the perpendicular distance. So you're looking for a right angle. And again, the two bases are going to be the two congruent polygons, and they'll be in parallel planes. So meaning, like for example, in the classroom, parallel planes could be like the ceiling and the floor. So they're parallel to each other. They don't intersect. To name it, it's going to be the shape that you have two congruent polygons for. Let's go ahead and see what a pyramid is. So a pyramid, its base is going to be a polygon, and then it's going to have n number of sides. So like if your base is a pentagon, then it would have 5 sides. And then those 5 sides would then form the 5 lateral faces that will meet up at the tippy top, called the vertex. So whatever shape is on the bottom, if it's a square, then you're going to have 4 lateral faces. If it's a triangle base, then you'll have 3 lateral faces. This time, the altitude is going to be in the center of your pyramid. So it'll come down here through the middle, and again, you would be looking for a perpendicular segment. And it's also known as the height. And again, to name the pyramid, you would name it with the shape of the base. So again, just like before, since I don't have any congruency marks on that base, I would just say that this is a rectangular pyramid. If you had congruency marks on it and they were all the same, you could say it's a square pyramid, but we don't have that. Now, the next slide, this isn't in our textbook. However, it's just a little trick or a tool that you can use to double check that you've counted the number of faces, edges, and vertices correctly. And what it just states is once you're done counting the number of faces, vertices, and edges of your polyhedron, you can just add faces plus vertices. If it equals edges plus 2, then that would be a way that you could double check that you did the calculation correctly. So for example, in this picture, let's say that this is a cube. So if you were to count, you have 6 faces, you have 8 vertices, and 12 edges. So if you do faces plus vertices, which is 6 plus 8, you get 14. And then the number of edges was 12. So edges plus 2 also equals 14. So it's just a way to double check that you've done it correctly. I am not going to test you on Euler's theorem. It's totally optional if you want to use it. Now let's just go ahead and go through some examples and determine if something is a polyhedron. If it is, we're going to count edges, faces, and vertices. So the first example, notice I've got congruency marks on my base. It's got 4 sides, making this a square. So yes, this is a polyhedron, and the name is going to be a square pyramid. And now I'm going to go back. I'm going to count the faces, the vertices, and the edges. Notice I have 4 triangle lateral faces and 1 square base. So I have 5 faces. I have 5 vertices. I actually have a vertice here, 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 and here. So 1, 2, 3, 4. And then the vertex up at the top. So I have 5 vertices. And then I have 8 edges. I have an edge going around up 1, 2, 3, 4, 5, 6, 7, 8. I have 8 edges. And if you want to try and double check your counts, remember you can do faces plus vertices will equal edges plus 2. So 5 plus 5 is 10, and 8 plus 2 is also 10. So using Euler's theorem, it does work out. But again, this check is totally optional. The next solid is not a polyhedron. Notice this curved side. So anytime it's got a curve to it, it is not a polyhedron, and you will not give this a name. It looks like it's half a cylinder. The next one, here's where they're trying to trick you. it is not sitting on its base, but the shape that you have two congruent figures for are these triangles. So you have two congruent triangles, but then you also have three parallelogram lateral faces. So this is actually a triangular prism, because you have two triangle faces. More specifically, it's actually a right triangular prism, but again, all I need to know is it's a triangular prism. I have 5 faces. I have three rectangles or 3 parallelograms and 2 triangles. And then I have 6 vertices. So I have a vertex 1, 2, 3, 4, 5, 6. And then my edges are all of these 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 edges. And again, if you want to do Euler's, faces plus vertices equals edges plus 2. So 5 plus 6 is 11. And then edges were 9. 9 plus 2 is also 11. And again, just an optional way to double check your count.
What makes it a triangular prism instead of rectangles?
Because it's whatever shape you have 2 of. So the 2 congruent bases is what names it. So you got to look to see what you have 2 of. And again, notice how they're trying to trick you and they're not sitting it on its base. They're sitting it on its side. So you have to be careful. So the cross section is if I were to take a plane or just take something and slice through my solid and then pick up the piece that I cut off to see what kind of shape you have in that cross section. Now, in all of the slides here, the cross section will be the purple. So in this particular pyramid, this was actually a triangular pyramid. And once I took the red plane or that pink plane and I sliced through the blue pyramid, the cross section, when I pulled that top piece off that I cut off, the shape I would see, my cross section is a triangle. Now, every time you slice through your solid, it's going to be a different shape that you see depending on the shape. This is actually should just be triangle, not triangular. So the shape I'm seeing when I slice through this is a triangle. And again, the original shape here was a triangular pyramid. But the cross section is a triangle. Now the next slide is going to have the first 4, A, B, C, and D. These are all cubes. The last figure, E, this is a cone. Now notice A, B, C, and D, they have all sliced through that cube at different angles. And for each slice, it's a different cross section. So for the first one, since it was a cube, once they slice through it horizontally, my cross section for this one is a square. But soon as I try to slice through it diagonally, again, notice my cross section there is a rectangle. And then if I try to chop off like the 2 corners there are part of it, then this cross section is a trapezoid. And then if I only try to chop off the top corner, this is a cube. I'm sorry, this is a triangle. The original shape was a cube. So this cross section, chopping off the corner, is a triangle. And then the cross section of the cone is a circle. So it's like if you sliced it and then you picked it up, what shape do you see? So in all of these pictures, it would be the purple.